Good morning, folks. We're watching another plasma filament release on our star. I hope you're awake, alert, and ready. We've got 12 science articles to hit, 5 stories about the weather, and breakthroughs from Earth into deep space. As always, we're going to begin with the last day on our star at spaceweathernews.com, and we are finding the only prominent feature being the northern coronal hole. It will hit center longitudes today, is set to deliver intensified solar wind early next week. Meanwhile, the solar wind currently at Earth is meager. A weak stream descended down into further ambient quiet plasma flows, and geomagnetic conditions are unsurprisingly quiet. We're off to Australia where rain, wind, and hail lashed the Gold Coast and surrounding locales. Damage came fast, and the hail once more hit dangerous levels. Once it starts covering about half your hand, you have ventured into territory where a strike to the head could be the end. Of course, watching for other things that could fall on your head is a good move in a storm too. Folks, the Great Lakes have been at the edge of overflow for months now. Record high marks, and that means extra coastal erosion, and mega ice block tsunamis from wind will be extra harsh this year. Looking ahead, we've got major weather coming to the U.S. and Europe tonight. Gulf low will tear up the eastern seaboard, while across the pond we're going to the edge of the North Atlantic low, which will drive Mediterranean storms and mountain snow as it dives towards Greece by tonight. Let's get one more on weather here, looking at El Niño and the rise of disease. Hanta, cholera, plague, dengue, and more. These diseases and their periodic flare-ups and outbreaks are largely driven by environmental factors. The right warm front can triple the soil microbe population. The right wind carries it to different places on the dust in the air. The food response and the people that eat the food, plus their responses to environmental changes. Link and video are below. Up next, we've got the new ionosphere data, but truly, I have to admit once again, these are exceptionally underwhelming. While they are able to see things like the solar eclipse effect on the upper atmosphere, there is little in terms of small-scale ionization detail, whereas a closer look at higher cadence could deliver valuable information about the weather and lithosphere-ionosphere coupling known to happen before earthquakes. But alas, this is what we've got. Up next, we're going out to Mars, where we've got 2 stories from the red planet, and the first is a mapping of its winds. In one of Maven's more impressive feats and one of the more impressive visualizations of them, we are able to see the elevation-driven wind flows and how the cell's vertical components are measured from above. Just another in the long line of discoveries and scientific gifts from Maven on the formerly Earth-like planet. And speaking of which, there's a very Earth-like aurora on Mars. It's actually very common there, and it's called a proton aurora. Solar wind hydrogen ions strike neutral hydrogen in the upper atmosphere, steal an electron, and cause an ultraviolet emission. Sticking with the solar system, but going out to Jupiter next, and the cyclones at its south pole. Not only do we have beautiful images, but recognized patterns. Folks, NASA drew those lines on there, and indeed are recognizing that geometry in the article. Now, while they skew to the optical capability on the multi-wavelength shots, let me remind everyone that the shapes sculpted by the electromagnetic events are simple functions of that energy and how it naturally tends to modulate its surroundings in the universe. When it comes to finding water on other planets, we really should just be looking at the smaller ones. Sadly, most known exoplanets are Neptune to Jupiter size, and it's looking like those have less water vapor in the atmosphere than expected. Remember, it's the rocky planets that contain the other half of that equation. The stars are giving the hydrogen in their wind, but one of the most common elements in space rock is oxygen. Interesting piece here on stardust, the nova remnants and what happens to them over time. What happens when a new solar system forms in the wake of that nova, and why will that dust not be homogeneously distributed through the new planets? The short answer is volatility, stickiness, and the battle between the star's gravity and its outward electromagnetic wind. Scaling up from the planets and dust to stars and pulsars, the nicer release claims to do something seemingly impossible, get a surface map of a pulsar, and especially focus on the hotspots, which actually took them in another direction, leading to the realization that this pulsar is currently in quadrupole mode. The global toroidal and more confined poloidal field structures were shown not only in the surrounding material, but in the position of the surface hotspots, which they also found to be changing over time, not unlike a large cloud storm on Earth, a sunspot on the Sun, or how the coronal holes morph, come, shift, and decay. We're still scaling up here. The Hawk project to find dark matter. Another mega collaboration where I'm sure these scientists had some gruelingly intellectual conversations and some quality time together. But when it comes to finding dark matter, I will give you 2 guesses as to whether or not they found it, and unless it's your first day here, you only need 1. Let's go next to a quick note about the center of the galaxy and the potential for a small, close-in orbiter in between the Sagittarius A central nucleus and the S02 star. The note is that the gas and dust and plasma torus whipping in that region, already known to exist, has vastly more than its effects of gravity, as do all plasma torus structures, which are already known to exist at the center of the galaxy. Up next, a wild story from a group of MIT, Army, and other scantily named groups and individuals has found that the rules of electromagnetism must be applied down to the quantum scale, bridging the gap, and elucidating that optical fields affect light polarization not just in their line of sight but in the entire surrounding area. Did you hear what I just said? Now consider how that would affect our views of the heavens and scale it up even further into space as we go deeper into time and distance. No wonder there are so many mysteries and poor cosmological theories. We are looking through a kaleidoscope. Lastly, folks, a paper that details the sun-to-Earth evolution of a CME that erupted as a filament collapse back in 2013, and they are saying that the critical component missing in previous models of CMEs is the accumulation of material on the leading edge of the shock, or the electromagnetic boundary shell of the eruption. This is a critical component of everything in space, from nova explosions to the density wave that hits before a coronal hole. The density is the accumulation on the leading edge, like snow on a shovel blade. Folks, this is exactly the same mechanism that concerns me about the large-scale structure of the galaxy. The plasma cosmologist in me could probably die happy at the recognition of the large electromagnetic structure, but the catastrophist in me knows what that means for a cyclical trigger from the galaxy, causing our star to show us her dark side. We discussed cosmology and catastrophe here today, and those are 2 of the 3 movies we put out in 2019. All 3 are linked below at our channel page and at our website homepage. We greatly appreciate your support. We've got wind map forecasts and shots of our star to close, and of course we'll do this all again tomorrow, right here, but right now it's 4:45 a.m. in the new Valley of the Sun. Eyes open, no fear. Be safe, everyone.